Here we go. This is the second chapter, elements and compounds. Okay. So in this chapter, basically, we're going to be talking about generally naming compounds. All right. So let's go to the first part here. So you have something called elements and compounds. Now, if you look at the periodic table, okay, let me see whether there's a periodic table here. I think there should be one, no? Okay. Now, if you look at the periodic table, right, everything that you see on the periodic table, these are all called elements, okay? Everything here are elements. So there are 118 here, 118 can you see here? So all of these are classified as elements, right, up to here. So every single thing is an element. So that's first thing. Now the other thing which is called elements are all all molecules, okay, all molecules which are made up of the same atoms. Okay, all molecules which are made up of the same atom. So like for example, let's say oxygen, hydrogen, chlorine, bromine, iodine, ozone, okay, anything else that you can think of which is like this. All right, these are all classified, okay, let's say like fluorine, all of these are classified as elements as well. Okay, so first thing is all this on the periodic table, everything is an element, and all molecules which are made up of the same atom. So these are all classified as elements. Okay, now if you look at the periodic table here very quickly, or everything which is in blue are metals, everything which is in green are non-metals. So you notice that there are more metals than non-metals. Meanwhile, the ones in the yellow here are called metalloids. Metalloids have characteristics which are some characteristics like metals, like for example, they have high melting points, they might conduct electricity, but then they have other properties of non-metals, like for example, when they make a compound, they make covalent compounds generally. All right, so their compounds are more covalent, not ionic or not metallic. All right, so that's one. So this first part here was talking about elements and compounds. So what are elements? Elements are everything that you see in the periodic table, and including all of the molecules which are made up of the same atom. Okay, so these are all considered as elements. Okay, so naming compounds. Now, you see this word here, don't get confused or don't get panicked with this word, binary ionic compound. Now, what does binary ionic compound means? It basically means ionic compounds, okay, ionic compounds made up only of two types of elements. Only two types of elements. Okay, you see, look over here, right? Look over here, potassium fluoride. So it's potassium fluoride. Potassium fluoride is only made up of two elements. The first element is potassium, second element is fluoride. So if you look at this, sodium nitrite, the first element is sodium and the second element is nitrogen. So only two elements. Look at this one, calcium phosphide is made up of one calcium and one phosphide. That's it. Only two different types of elements. So this is called a binary. So binary means bi means two. And then another example here is magnesium sulfide. Okay, so when you look at the names of binary ionic compounds, right, if you look at the names of the binary ionic compounds, the first name that you see, okay, the first name that you see is the name of the metal. In every case, it's the name of the metal. See here, it's the name of the metal. So this is taken directly from the periodic table. Meanwhile, the second word has this addition here, ide. Okay, fluorine becomes fluoride, nitrogen becomes nitrite, phosphorus becomes phosphide, sulfur becomes sulfide. So you keep adding this ide here. Can you see here? So it says here, okay, the N ion has an ending of the element name has been changed to ide. Okay, it's been changed to ide. So the first word is always the name of the metal, and the second word is the name of the non-metal. So if we look at this, right, if we look at this potassium fluoride, what we can do is we can separate potassium fluoride. We can separate potassium fluoride, let's say potassium fluoride, right? We can separate it into potassium ion and fluoride ion. Okay, in the case of this, it is actually, you can separate this. Okay, this is, you can separate sodium nitride. You can break this up into sodium and then nitride. Okay, when you break it up, in this case you get calcium phosphide, right? So you can break this up into calcium and phosphide. Here, magnesium sulfide. Magnesium sulfide, you can break it up into magnesium and sulfide. So these are the names of binary ionic compounds. So when you hear the word binary ionic compounds, you just need to know it is made up of only two types of elements. That's what it is. Okay. So so then you come to this one here that talks about polyatomic ions. Now, poly basically means this word basically means many. Okay, it means many. So in this whole sentence here basically means ions which are made up of many atoms. That's what this whole polyatomic ion basically means. All right. So an ionic compound, in ionic compounds, either one or both of the ions could be polyatomic. A polyatomic ion is an ion composed of more than one atom. Okay, more than one atom. So if you look at here, okay, so look at this. Look at this here. So it's made up of more than one type of atom. So there are 5 different types of atoms. So this is a polyatomic ion. So other examples of polyatomic ion is this one here. This is also a polyatomic ion. Okay, polyatomic ion. So it's an ion which is made up of many atoms. Okay, made up of many atoms, not many types of atoms necessarily, but many atoms. Okay, so these are called polyatomic ions. So there are many polyatomic ions. You can see some examples here. They are made up of many different types of atoms. Okay, these are all examples of polyatomic, except for this side. You see, this is only made up of one. Okay, this is one. So this is not polyatomic. This is also not polyatomic because it's only one. It's only made up of itself, right? The rest are can be considered as polyatomic ions. Okay. Okay, so the definition here you can see here. A polyatomic ion is an ion composed of more than one atom. More than one atom. So if you look at this, by that definition, these two do not fit the criteria. It must be made up of more than one atom. Okay, so this is not polyatomic. Okay, so do you need to memorize this? If you can memorize it, is good. It will be helpful for you. Okay, so these are some examples of cations. These are all cations with charge of +1, like hydrogen, ammonium, silver, copper. I mean, there are others that you can memorize if you want to, like for example sodium, potassium, then there is calcium, there is magnesium, but there are so many for you to memorize, so I guess don't really waste your time memorizing, but it'll be good if you can kind of know the names of the ions. Okay, all right, so when we come to naming ionic compounds, okay, this is example of ionic compounds. If you look over here, lithium hydroxide. So if you know the formula for hydroxide, lithium. So usually when we name ionic compounds, right, let's say for example you have a let's say you have a positive ion Am plus, and then you got Bn minus. Okay, so if you remember from high school, AnBm. Okay, if N equals to M, then then it is just AB. Okay, then it's just AB lah. So if N equals to M, all right, then it's just AB. So that's what it means here. So you see, like for example, okay, there's no example. Okay, I look at that. This is an example. Say lithium is positive 1, hydroxide is negative 1. So it is just LiOH. Okay, that's it. So in the case of calcium chloride, what happens is, you see calcium chloride. Am I right? So what happens is this two goes over here, and this one comes over here. So it becomes calcium chloride. 2 goes there. Okay, we don't put the 1. So this is how positive ions are combined together. If you look at ammonium carbonate, here, right, you can see ammonium, then you have carbonate. So what happens is these two comes over here. So it becomes ammonium bracket 2 carbonate. So what does this mean? It means that these two belongs to ammonium. Okay, so that is why we put a bracket and we put a 2 here. All right. Okay, so then that brings us to binary covalent compound. Again, the word binary means covalent compounds. Okay, covalent compounds made up of only 2 different atoms. That's what it means. Okay, made up of only 2 different atoms. That's what a binary covalent compound is. So the word binary means 2. Binary basically means 2. Okay, so let's look at some examples here. So these prefixes it'll be important for us to know, like mono, di, tri. Okay, so here comes the naming. Look at this example here. Okay, so all of these are examples of binary covalent compounds. So again, I repeat, binary means it's just made up of 2 elements, 1, 2. Okay, see, every case here is just 2 different types only. Okay, so that's why we call it binary covalent compound. Okay, let's look at the naming process. When we do the naming process, right, the first name is the name of the first element. You see, nitrogen. First element is nitrogen. First element is phosphorus. First element is sulfur. First element is chlorine. Okay, then what we do is we use these prefixes here. You see these prefixes here, mono, di, tri, tetra, and so on, and then we put it in front here. You see, but okay, listen very carefully. If the first element is single, we do not do this. We do not say mono nitrogen mono oxide. Okay, we do not say this. This is wrong. We do not say this. This is wrong. If the first element is single, we just leave it as it is. You see, like for example here, there's only 1 phosphorus, so we don't say monophosphorus, we just say phosphorus. Okay, but if you see, if the second element is single, okay, like say like in this example here, right, see the second element is single, so we use the word mono to tell everybody that the second element is single. The first element single means we don't say anything. If the second element is single, then we use the word mono. So like in this case, this was di-nitrogen. There are 2 of them, mono oxide. In this case, phosphorus, we don't say monophosphorus, we say pentachloride. Penta means, what is penta means? Here you see, penta means 5. So pentachloride. Disulfur, 2 sulfurs, dichloride. Okay, dichloride. So what, again, if you notice, what we are doing here is we are adding this ide at the back here. Ide. Okay, so this is dichlorine. Hepta means 7 oxide. Hepta. So basically you are telling people there are 2 chlorines and there are 7 oxygens. Dichlorine heptaoxide. Okay, so note, it says here it is accepted by IUPAC. IUPAC is the International Union of Pure and Applied Chemists. You can decide to write monooxide or monoxide, whichever. You can put double O's there or single O. It does not matter. Okay. Okay. So Okay, so all right, then we're done here. Very quickly, let's come to the last part here, naming acids. Okay, so again, there are some acids that you might need to know the naming process. Okay, so there are some acids here. So binary acid, again, the word binary means two. Whenever you talk about acids, one of the element is always hydrogen. So one element is always hydrogen. So when you say binary acids, one element is already hydrogen. So we're just talking about what is the second element. So if you look at examples here, binary acid could be like HCl and then HBr. Anything else? Okay, let's say HF. These are examples of binary acids. That means they are acids which are only made up of one hydrogen. Okay. Okay, so this is hydrochloric acid. Now, you see, if it is HCl liquid, then we call this hydrogen chloride. We call this hydrogen chloride. If it's HCl aqueous, then we call this hydrochloric acid. Okay, we call this hydrochloric acid. So the difference between liquid and aqueous. Aqueous means hydrochloric acid. If it's liquid, it's hydrogen chloride. Okay, just like HBr, liquid. This is called hydrogen bromide. But if it's HBr aqueous, then we call this hydrobromic acid. Okay, hydrobromic acid, that's the name. All right, so then that brings us to this part here. It talks about oxyacids. Oxyacids are also known as oxo acids. Okay, acids, typo. Oxyacids are also called oxo acids. So oxo basically, or oxy basically means there is oxygen in the acid. So look at these acids here, right? This is nitric acid. You look at nitric acid, there is oxygen in nitric acid. So nitric acid is an oxo acid. Sulfuric acid. So sulfuric acid has oxygen in it. It's called an oxo acid. Then there's carbonic acid, there's phosphoric acid. These are examples. So if you look at here, just very quickly, this was nitric acid. And then we have something called nitrous acid. Nitric acid has one oxygen. Nitrous acid has one oxygen less. Nitric acid has 3 oxygens. Nitrous acid has 2 oxygens. Same thing with sulfuric acid, H2SO4 versus H2SO3. This is sulfurous acid, sulfuric acid. So you need to know the name here. Sulfurous acid, and the other one was sulfuric. Ik is 4, us is 3. Okay. And the very, very last part. Okay, very, very last part here. It talks about hydrated compounds. Okay, hydrated compounds. So hydrated compounds are like this compound here. You see this? This is called, so you see this dot, if you see this dot over here. Okay. So this basically means it is a hydrated compound. This is called copper 2-sulfate pentahydrate. Pentahydrate. Hydrate basically refers to water. Okay. So what does this dot mean? What does this dot mean? So if you imagine copper sulfate to be a solid like this, right? If you imagine, so water, there are 5 water molecules which are physically attached to the surface of copper sulfate. Physically attached. Just like when you shower, there is water which is attached to the surface of your body. When you use a towel, you can wipe it off. So this water is physically attached to the surface of copper sulfate. All right. So let's say this is copper sulfate. So what you do is, if you heat this up, just like when you go and shower, if you go and stand under the sunlight, the water can evaporate. So what will happen is the copper sulfate will remain dry, and then all of the water will be evaporated off. So this is what it means by this dot here. It's called hydrate. So there are many others, like for example, if you look here, This is called sodium carbonate. 10, what is 10? 10 is called deca. You see here? 10 is called decahydrate. So this is called sodium carbonate decahydrate. All right. So this is this part here on the types of compounds. So basically, unfortunately for you, you might want to spend a little bit time memorizing these things. What I would suggest is you might also want to work out on some of the guided learning or revision questions. All right.